Good morning, everyone. Happy Monday. I hope you all had a great weekend. And I'm looking forward to getting back into the nature of code again. I need to open up my dashboard so I can see chat. All right, so this is all working. We're all good. Excellent. Minimize you. Okay, so for the last few days, we've been going through and learning ECS, which is the Entity Component System, to use with the nature of code, because we ran into problems where we had not with our walkers eating food, but rather with walkers eating walkers, because they were just a bunch of structures stored in vectors, a single vector. Then they sort of like manipulating a vector and said, okay, I need to remove you, but also I'm looping through you to like eat you, and then it got a little bit messy. But ECS allows us to do that a lot easier because we're using an existing system that keeps track of them. It uses a bunch of different vectors, but instead of like for full objects, essentially, where it's like, okay, the first position and index is going to be the first walker. And position 2 is going to be the second walker. It's actually going to be the first position is going to be the first array, the first vector is going to be all of the positions, and the second vector is going to be all of the, velocities, and then the accelerations, and then everything else. And then it's going to be a slice down vertical. That's going to be which walker we're talking about, or maybe it's even food, but they're all stored sort of similarly together. And I know on Friday I mentioned that I was going to look at Legion. Over the weekend, I took a really quick look at it. I looked also at the Rust ECS. Oh, what is it? It's a project to sort of determine which ones are faster. And it turns out that a library called ECS is the fastest in Rust, but it's also not actively supported anymore. So I'm really going with Specs, which it still is the fastest actively supported ECS according to that project. Anyways, I figure let's go ahead and get started here. We have all of these things. None of the stuff that we have here is gonna be able to stay. We have to start from scratch, which isn't really a big problem because we can get. I'm pretty sure we can get back to where we were pretty quickly using specs. So we need to like look through our to do and see what we really still want to do. So kill the walker if it runs out of energy. Yeah, we definitely want that. Start with less food. I don't know, like we still want to start with, we probably still want to start with a bunch of food. Or yeah, we want to start with a bunch of food. Maybe do we want to like then add in a whole bunch like on the first frame? So like we'll just say start with some food, implement a food struct. Okay, so we're not going to do structs anymore, or at least not in the same way. Right, so what this is going to be is just add food every n seconds. We do want to use delta time. Want to wrap the screen. So I've been thinking about this. do I really want to wrap the screen? Or do I want to sort of like, yeah, they can get, over to the edges. I think I'm going to not wrap the screen this time, but make the simulation bigger. So keep everything in the arena. Poison a food after it ages. Yeah, that looks fine too. Different shapes for food types. Sure, yeah, we can do that pretty easily. Use BBGZ properly. I don't even know what I meant by that anymore. Less poison, more food. Implement render sizing. I think we have that automatically right now whenever we just do this. Maybe, I don't remember. Add 4-space walker. Okay, so we're gonna have walker that moves towards food. Remove the enum, use the box dynamic type hash map and the trait. I don't need that. Walkers can eat each other. Yes, that's definitely important. Refactor for dry. We're gonna get that like a lot easier with ECS too. Create screenshots for thumbnails. I think that would be really nice to have, is like a spacebar or something, and we'll get a screenshot of whatever's on the screen. And I have Carboco format running automatically now in this in this editor. All right, so and then these are all still sort of the same. So step one, we're going to create the arena. So create the arena. Then I want to create a bunch of food that's randomly walking around. So start with some food. And then the other thing is food randomly moves around. I decided that I wanted to have the food is going to be our old random walkers. And so the only walkers that we start with are going to be the attraction walkers. So the food randomly moves around. We're going to add this food every n seconds. The food is going to poison and then disappear. So food goes away after some time. Okay, so once we have the food situation, then we're going to have a walker that moves towards the food. Walker can eat food. The walkers can eat each other. The walker dies if it runs out of energy. We can use, let's see, use delta time. I think that's going to be default. We're going to want to do that. Keep everything in the arena. I think we want that in here too. Different shapes for food types. I think that's up there. Yeah, okay. So I think this is a good place to start, which of course means that none of this stuff that we had previously is going to stay here. So I'm just going to go ahead and let's delete it. Okay, so we're going to delete foods and walkers. That leaves us the library and main RS. Let's see what's in main. So we're doing, all right, so we're doing the new style here. So we're just run, game, ecosystem project. I think we even have a new one. So if I do use BGV, run, and I want to switch this over to run oh, you know what? I don't have the right version. That's the problem. Okay, we're gonna make you 1.0.0. We are also gonna need specs. If I remember correctly, it's it's like 0.15.1. I'll just say star so that way we get the latest one when it comes out. No, 0.15.1. All right, so GZ run, and so now I want to do, we're gonna run dim. All right, so here's our game, our width. Let's make this this arena. It'll be nice and big here. So maybe something like, I think 2,000 pixels wide is what I have here. Although, like, the screen that I have going out is 1920. Let's maybe do like 1920 by, what is it, 1040? I don't remember. Oh yeah, these need to be .0, .0, title. And the author, me. All right, so that will give us that will start us up. We can't find crate for ecosystem. Well, it's in here. It's probably upset because of all these. We can pretty much start over with this, where we're going to want to say pub struct game. It is game we're looking for, yeah. We don't necessarily have anything in here that we're caring about right this second. And so we're just going to return a new game. Oh, I think I can just do reference to game. Oh, expected type mute. Okay, don't like that. The trait is the event handler is not implemented for ecosystem game. Right. So in here, I need to now add in the event handler stuff. I use GZ. I think it's event handler. We're also going to need. Let's go ahead, grab you out. We're also going to need in here. Oh, what is it? It's the response. Game response? Oh, man, I forgot what it was. Game Game result. That's what it is. Okay, so impl event handler for game. So we're going to have a function update. Right, this is going to bring in context, which means we need context here too. Which is mute context. We're going to return a game result. And we're just going to return OK. I don't think we're going to take anything else in. We're also going to return a game result here. Okay, so we can set our background for this. So what is that? That's going to be a graphics. We need graphics. All right, so it's going to be graphics. Background. Oh, clear the screen to the background color. So pass in context and then graphics black. And then we want the present. So it's going to be graphics, present, add context, and then return whatever this is, which is a game result. You're all upset. Update. Oh, you know what? This is something that sort of bothers me a little bit about like RLS's automatic system here is that it doesn't add in what I need there. Okay, so that should be no errors. We can cargo run this, it'll compile, and then we should all be good. Probably should have started this ahead of time. I kind of forgot that I'll need to recompile it because we switched to a newer version of oh, and we're adding in specs. So initially I was thinking I was going to have a camera system and then have like a really big giant arena. And over the weekend I decided I did not want to do that because the if you just have like a blank, you know, either white or black or a single color background and then a some item like moving around on it and the camera is following it, you actually can't tell that anything is moving at all because there's nothing relative. So it just sort of looks still, then something else comes across the screen. So I'd have to fill up the entire thing with like tons of food or tons of something else just to make it look like we're moving. Okay, so I see this is exactly the size of our yeah, that looks maybe tiny bit too wide, but it actually looks appropriate. So let's I mean, we could even draw a border around the outside just to make sure. Let's, and do I want to do that in specs or in just draw that out here as the interface? I'm almost thinking that we could have specs draw that. Chantilly, good morning. Happy Monday. So let's start bringing in specs. So specs, and then We need world. World ext. Components. Don't remember what else we're going to need right this second. But let's go ahead and initialize our world here. So I'm going to start with world. You are a world. Equals world new. And we'll throw you in here. All right, so you claim you don't need to be mutable yet. Probably when we like go and update things. So the first thing we want is the interface interface for this, and I don't think we're gonna need a. It's just gonna be a system. So I still haven't figured out a good way for myself to organize all the systems and the components and everything else. I can create like a single file or multiple files. I'm not exactly sure. So I'm gonna say we're gonna have a struct. This is gonna be essentially interface system. Actually, we're not going to have anything in here. It just stops like that. We need system. Guess we don't need component yet. All right, so impl system for interface system. We're going to manually set the type equals system data, which I can't remember if we need to pull out for this. Probably we do. System data is, I think it's just a tuple. Oh wait, no, got it. It's system type, system data equals, and this is a tuple. And so in here, what exactly do we need? I don't know if we need any information or data. You know what we do need? The arena size. So we could set the arena size to be like whatever it is when we first launch the game. Which we see that here in like 1920 by 1040. If I just set, let's do this here. Width. I'm gonna make this 1900. And now we can pass in the width, height, really. Okay, and now you will be the width and the height. So if I even if I change it a little bit later, we can we'll still like keep that as it is. So in you here, we're gonna have the arena width. Okay, so world, we create a new world. And so I'm thinking this is going to be a resource. We're not going to add it into the game structure. We're going to create a resource component here. So we're going to have a struct arena size, and it's going to be a tuple that has an F32 and F32. And that's pretty much it here. Now we need to bring in component. No, it's not component. It is. I forgot because it's a resource. It's not the same thing as a component. So we're gonna derive. Is it like general? Oh, it'll let me know which one I'm supposed to do. So inside of world, we now need to make this mutable, and we're going to world.insert the arena size. And the arena width. And arena height. Just like that. And it should yell at us. Oh, it might not because we haven't like actually implemented this yet. So then we're going to need read. And so here we're going to say we need read of arena size. Oh, and it's like that. Function run, I think. What are you upset about? Default, that's what it is. Derive default. That should make you happier. Now it's just saying missing run. Perfect. Okay, so in run, we're going to bring in mutable self. Then we're also going to bring in not mutable. We're only reading the arena size. So this is going to be the size self system data. We don't return anything from this whatsoever, and now we don't need to loop through the arena size because there's just one of them. It's a resource. Also, you're saying no need for parentheses. We're gonna automatically grab it out of there because it's a tuple of 1. Okay, so now that we have this, I can use it to like actually draw. So the other problem is I need to get, for this interface system, I wonder if I want to like actually draw this, like just make this as a draw, because it needs to have the context in it to like properly draw it out too. So maybe instead of interface system, this is just the draw system. Katali, good morning. Happy Monday. Okay, so draw system, and then in this struct, we're going to have to store mutable context, which of course means we need a lifetime for this. I'm going to make it the same lifetime here. And that will just make it a little bit easier. Everything survives as long as it is. So once I have this, now I can now draw my sort of, I guess it's going to be a rectangle, or it's going to be like 4 lines around. Let's think about this. We can do a square with just the outline. That's probably all we really want to do. It could be 1 pixel on the inside of everything. Let's see if that draws. We have to create the mesh first. So let So we can call this like the border mesh. And this is going to be graphics. We need to use mesh builder. And so we want a dot rectangle. Think you can use, well, it's actually not a pure, ooh, I can. I forgot about that. Let me see. We have BBGZ, we have mesh. Oh, I don't know what's in here. Do we have to create a new mesh? Huh. I was hoping that it would automatically complete that for me, but I guess we're gonna have to go to the documentation. Okay, so we have mesh here. It's create rect. So it's BBGGEZ mesh create rect, and it's just a full function that takes these things. So BBGGEZ mesh create rect. There we go. Okay, so width, that's going to be our arena size. So we're going to say arena size dot 0, arena size dot 1 for the height. The width, we can probably do this something like either 1 or maybe like 2 pixels. Color. Oh, okay. I foresee a slight problem with this. And the main problem I have is that I just want the outline. So I think this create mesh is going to create, yeah, it's going to use draw mode fill. And I want to use draw mode the outline. So yeah, this won't work. It's a really good idea, but I'm gonna have to do graphics, do mesh builder, new dot rectangle. So here's our draw mode. So graphics, draw mode. I want stroke. Width, we'll just do this to 2 pixels. The bounds. So we need a rect bound. And I think I can do graphics rect new. Yeah. And then we'll have X and Y. So like the top left, so 0.0, 0.0. What's next? Then the width and the height. And then the color. I think white is probably fine for the sort of outline border. So we can just do graphics white. After we, let's see, rectangle. What else do we need? That's everything. So then we need to build it. We're going to hand it in the context, which is going to be self.0. And I think that's, oh, then there's going to be the draw. So we're going to have an unwrap. Because we don't have like a return value on this, I don't think we can. So now we're going to graphics draw, handed self.0, the drawable, border mesh, and then any params. This is gonna be our graphics draw param default. Just whatever is the default. That's all we care about. And then of course another unwrap. The or X plays. Good morning. Can I explain unwrap in Rust? Yes, absolutely. So it's an error handling thing in Rust, and so the idea is that let's take a draw here. Draw returns something called a result type, and it's like behind the scenes, it's an enum that has two potential paths for it. It has the success, it worked out okay, which is an okay, literally okay, and then whatever value that is inside. Or it's an error type. And so when I use unwrap, I'm saying, look, I don't really care. I promise you this should work. If it doesn't work, go ahead and panic and crash the application. So that's what the unwrap is doing. So I think, are we going to draw yet? No, we're not going to draw yet because we're not actually using this. So pretty much you don't handle the error there. You just suppress the error, but it's implicit. Well, I mean, I'm having to do this because of using ECS in this way. I can't pass back out of it just due to the way I'm setting up the system. A really good method of doing error handling is what this is doing here, which is a return result, a return of a game result. So graphics present returns this result type, but I'm just passing it back on up to the parent, and then as high up as possible, I'm handling that error. It's just like try catches in other languages. You want to sort of handle them in very specific spots. Raven Legend, good morning. But it's implicit. I guess in this case, it's explicit that I'm telling it to crash if it can't unwrap it. So I need to, in draw, we need to run the arena size system. So we're going to say let mute, I guess it's going to be our draw system. So draw system, and we're going to pass into it the context. And now we can use this draw system dot run now. Run now, and we're going to pass it self.world. And we're going to need run now for that to work. That's what I meant, I guess. My bad. How would you catch in Rust? Oh, yeah. So catching in Rust is as simple as actually writing an if statement for this game result. So I want to say hey, if it's the error, then I want to go down this path. If it's not the error, if it's okay, I want to go down this path instead. So that's how you would not just panic at the end. This being a simulation, which is very similar to game development, oftentimes crashing is sort of what we do. But in business apps, definitely handling it is really important. So let's see if we've got a nice square on the outside now. I don't know if I'm outside of the arena or the inside. Hey, take a look at this. So we have a nice little 2 pixel border on the outside of our entire window. So that's perfect. I think you can all see that too. What am I coding for? This is I'm going through the Nature of Code book by Dan Schiffman, and I'm on the Chapter 2 Ecosystem project. I had to take a break to learn ECS so that I could apply that to this project. Okay, so we're going to what's the first thing we want to do here? We create the arena. We got that. We need to start with some food. Couldn't you do that with GG Easy's window object? Oh, you mean like get the arena size? Or is it like actually drawing the border? I don't know if I can draw the border with the window object. The border. Oh, I mean, maybe. I don't know. I don't think I've tried that or looked into it too much. Okay, so now I want to create an actual component that's going to store my the food. So we're gonna have a structure here. We're gonna call this our food. And what is it gonna store? I think it's just gonna store the health of the food, like how many calories it has, so to say. So I'm thinking this will just be an F32, just like that. I don't know if I even need anything else, but we're gonna have to derive that this is a component. And I'm gonna let this be the dense vect structure, which means I need to pull that in. Dense vect storage. Abstract component type doesn't have to be copy or even clone. What's wrong with you? Can't find derive macro component in this scope. Component, you're here. Am I doing this wrong? Oh, you know what? Yes, I am doing it wrong because I'm not bringing in. I'm not doing the thing that like automatically brings in the macros properly. What operating system am I using? I'm using Ubuntu. I think it's the latest version, unless there's been an. I think I'm using 19. So we need to go to what is it? Specs, the book. This here. We need this line. And that will make this work. Perfect. Apparently we don't need system data. It'll just work it without it. Okay, so now we have our food, which we're just gonna have just be the health of the food. We're also, well, let's just bring that in. To begin with, let's just start with like one food, let's say. So let's, actually it's a little bit easier than that. We're gonna say world.register. And then now we're gonna say it's gonna be food. and then like maybe the starting health. So that food calories equals, let's start at them at like 1.0. So I'm registering, take 0 parameters. Oh, right. You know what? I forgot. It's actually done like this. Food. And I'm at, now I need to remember how to do it properly. Register. Oh, right. Okay. Position, velocity. We're just doing that. We're registering. And then how do I insert into it again? Or like adding in. We register and, oh, right, this create entity. So food, like that. Definitely a turbofish. Also, good morning, Danny. Oh, wait. Opposite. Food.register turbofish here. There we go. So the food is not going to be all that helpful unless we have some sizes for it and the location. So let's go ahead and also do that. So we're going to have derive component struct location. And then we're going to want this to be NA algebra of vector 2. So you are a vector 2 of F32. Then we're going to also want to derive component struct. So we have a location and we also need a size. In this case, it should probably be like a radius because it's a circle. So a radius, and this is simply going to be an F32. And I keep on forgetting that with these type of structs, I need to semicolon them. All right, so now I can use register them here too. So world dot register. We're going to have our location. And our radius. I keep on forgetting like to finish the turbofish syntax. And let's see if we can get, I don't necessarily think I need the color or anything else for that. Maybe I do. Probably I do, but for right now, let's just not worry about that. And I'll do that later. It's really easy to add these in with ECS. So let's create our food entity. So world.create entity. Cool, you're not giving me anything here. Well, that is it. World.create entity and then dot with. I think I'm missing builder. Okay, so it's gonna be dot with, and now I'm gonna add these things in here. So our food is, well, so it's gonna have food of food calories dot with, Then we're going to have a location, which is a vector 2 new. And so where are we going to put this? If I just put this in like a random spot, like, I don't know, 250.0, 250.0. Cyantan, good morning. Let's see, with location, and then dot width, and our radius. And let's make this like, I don't know, 3.0. Is there like a build? I think there's a build. Yes, there is. All right, so that gives us, this is our first entity, which is a food. And so in our draw system, we're going to now need to read in all of these elements for the food, and then we can actually create the meshes for them and then draw them out. So I'm going to start here by not worrying about creating the meshes. I mean, is that true? I think it's true because the food mesh is going to change. All right, so I'm going to read the arena size, but I also want to read storage. Okay, so read storage. And here we're going to say, okay, we need food, location, and radius. So food. All right, so now that we have all of these, in this run, we bring in arena size, and we're now also going to bring in, oh, and this is where the tuple comes back in. So we're going to need in food, location, and radius. Now that I look at this like food here, this is not really all that helpful. So I'm thinking I'm going to rename this from like food. Food is too specific. This needs to be something like health. So I'm going to name this to just health. Our food calories can begin with that because we're just going to start you with health like there. Health, and now you are health. All right, so we're going to bring in health like that. In our function, so we're creating our border mesh, we're drawing the border out. After we draw the border, or maybe we should do the border last because it should be on top of everything else. Let's go ahead and use specs join. So we need to join specs together. And what we want to do is we now, oh, it's not a function. I want to now loop through all of everything that we sort of grabbed together here. So for, and we're going to get health, location, radius, in health, location, radius, dot join. And now for every single one of these loops, I'm getting all like the health, location, radius of whatever it is that has all three of these. which we happen to know is the foods right now, but later on it'll be everything. And so let's just draw these as green. I think that's what we decided. Yeah, green. Do you think reading nature code is a good way to learn Rust as a beginner? No, probably not, because nature of code actually all of their examples and code everything else is in Java, or specifically processing, which is kind of like Java. I would recommend the nature of code. Sorry, not that. I would recommend the Rust book by which is off of the official Rust page. I think that's an excellent way to sort of begin and start through it. Okay, so now that we have the for loop here, let's go ahead and create the meshes. So let mesh equals graphics mesh builder new. So I'm thinking this. I was thinking we're gonna make everything a circle right now. We can make, if we need to make it a square, what gets interesting is that I have to know that this needs to be a square. And that's really fascinating. So I guess storing the mesh ahead of time would be really nice for this, because then I could just say, it's the mesh in here. So maybe let's do that. So in here, we're gonna derive component. We're gonna have a struct mesh, and in here we're gonna store graphics mesh. We're probably gonna need an impl for a new on this one, just to make it a little bit easier for us. So impl mesh. Okay, so what do we need to create our mesh here? So let mesh equals mesh builder. Oh, I guess it's new. Okay. And I think I want to store, mesh. You know what? So I need to store like whether or not it's going to be a like a circle or a square or anything else. So how about for right now, everything is just a rectangle. And I think with a square, I can use the BBGGEZ one. So the mesh is going to be G mesh create square x. So like our size for this, I think. Oh, the location. So we'll just start with everything 0.0, 0.0. The side. So we need our size. We need a color. So for right now, let's just make this green. This will be 0.0, 1.0, 0.0, 1.0 for full opacity. And then the stupid context. I keep on forgetting. We need the context in order to build the mesh here. Okay. I don't have the context up above, so I'm not going to be able to do this properly. Okay, fine. Fine. I'll just have to build them here like this. And everything right now will be square, but I'm gonna have to have like an enum to like store which type it is, and then we'll just read that, and then it'll be interesting. Do you think, let's see, You plan on learning JavaScript, then Python, followed by Rust. Yeah, I think that could be pretty good. JavaScript and Python are both really fun languages, and you could do a whole bunch with them. Okay, so here, Mesh Builder new. So I think we can actually get away with that square. So G mesh create square. Okay, so for our X, here's where our location is. Now our size, like this is going to be the upper left of the square. So I want to shift it to the left by half of the radius. Should I just do, I should probably just do circle. Let's just create circle. Create circle. Okay, so this will be the center of it. So it'll be our location dot 0 because it's a tuple. Dot x location dot 0 dot y. Our radius is going to be our radius dot 0, and our color. We're just going to make this green for right now. So graphics color new. And then our context, which is self.0. I think that's all we need here. Oh, it's color with a capital C. That gives our mesh, and now we can just draw this out to the screen. So graphics, draw, self.0, mesh, draw params, default, and I don't think I need anything else, and then we'll unwrap. Oh, health. Yeah, so I'm not really using health here for the drawing at this point, which means I don't really need this. Not game, just here. So you. You go away. You go away, and you go away. All right, let's see if we've got anything drawn to the screen. There we are. Here is our sort of food sitting here, drawing on the screen. Now, what's a really cool thing here is I can now get RNG and just create a whole bunch of them at the very beginning. So let's do that next. So I have you as another one of these. Is it Rand? I think it's Rand that's been exported out like this. So we need Rand and then Rand prelude start like that. Okay, and then in new, we need to create let mute RNG equals Rand prelude. Okay, so where's our Rand? Right, it's Rand create thread RNG like that. So if I want our location to be completely random number, have I ever watched the series Mr. Robot? I watched only a few of the episodes. It was too dark for me. Like it added too much stress to my life. And I generally try to watch TV to like have less stress. Okay, so we're gonna do rand gen range. And here we want, so I want all my stuff to be between, let's say, 10 from the left, and then all the way to the arena width, minus like 10. And I want this to be exactly the same for this other one, except I'm going to use height. Okay, so this creates a single entity for us that's going to be our food. But I can wrap this in a loop. So for, I don't really care about that, so it's underscore is our catch-all in 0 dot dot. So let's do like, I don't know, 25 of them. And we're going to dynamically insert 25 of these foods in here, like that. And everything else should just work. Let's see if we got 25 foods. They're all sort of randomly positioned around inside the arena. Okay, that's pretty cool. So we start with some food. We can make the food randomly move around next, or we can make the food poison and sort of go away as it dies. I'm not really sure like which one I want to do. Like both of them are like valid. So if we have the food randomly move around, the way that we're having movement in this simulation is that we're going to have an acceleration that's going to be set to 0. We're going to have a velocity, and the velocity is going to be automatically sort of like changed, like set to a random one for the food. And it's going to be set to like something else for not food. So let's see. Essentially, we're going to just sort of like be hitting it constantly a little bit in each direction, like in random directions. And that's going to set the acceleration. So we need acceleration, we need velocity, and we have location. And that's kind of it. So let's go ahead and create some components here for this. Derive component. Okay, so struct, we need our velocity. This is going to be a vector 2. We also need, well, our velocity is going to be default 0, so I probably want to 0 for, impl for this. I'm going to return a velocity. This has a vector 2 new. All right, standing still. Derive component. And you know what I realized? This is exactly the same, except it's going to be our acceleration. Acceleration is also going to be a tuple struct of vector 2. Yeah. So let's go ahead and register these. Okay, so we're going to register our velocity. our acceleration. And so now we're going to give each of these foods here a velocity and an acceleration, like that. Okay. Now we want to update and move the foods. And so this is where it gets a little bit interesting. Well, I guess like it's only going to get interesting once I have non-food types on here. But I don't think we're going to get to that today. So let's just go ahead and make them move around. So we want a move system. Move system. I don't know if I'm going to want to change this into like a move food system later on. I might. Actually, I don't need this. I don't need this at all because I don't need the context or anything. All right, so we're going to impl system for our move system. Crazy Wolf, hello, good morning. Okay, so we have a type system data equals. Okay, what are we grabbing here? We need the location, the velocity, and the acceleration. And the location is going to be updated. So we need write data, write storage. You remember a stream where I built something similar? Is this a rewrite? Yes, this is a rewrite of the Nature of Code ecosystem project. I ran into, I coded myself into a dead end. So I took some time off to learn ECS. And I'm using that system now with the ecosystem project. And I'm hoping it'll make it a lot faster and a lot easier. But I am having to redo it all because ECS requires my data to be stored completely separately. Okay, so we were going to want to write storage, and this is going to be our location. Read storage, and this is going to be our velocity. Is that true? Do I want to read or also write to the velocity too? Because I almost feel that our velocity is going to be random here every time. And then read storage. Is acceleration. Oh, so I feel that this might have to be write to multiple things. So write to velocity and location. I feel like we're going to need write storage to velocity. Ooh, I probably want a structure for updating our velocity, then another structure for updating our so a system for updating our velocity, and then a system for updating our acceleration, and then a system for updating our location. So this is, I think this is going to be an update velocity system. In which case, we don't really need the location at all. We don't need anything, just the velocity here. And then we'll have our function run. We'll have our, what is this? This is going to be our velocity. And we're going to then do the join. So use specs join. You are mutable, so you have to be mute. And now I want to do the loop through this. So it's going to be for velocity in mute velocity dot join. All right. So now I can update the velocity and just set it to whatever I feel like. I'm gonna need our random number generator. I kind of feel like I should throw this into our resource, and then I just have it everywhere. And I can do that pretty easily. So here's our other resource. So let's derive defaults, struct random, and this is going to be our thread RNG is going to be the type in it. World.insert, and then it's going to be random with RNG. Oh, okay. It really doesn't like that because RNG is like, okay. It has a lot of other things in it. I'm just gonna have to recreate this in the middle here every time I use it for right now until I figure out some other better way of doing that. Because I don't also necessarily want to yeah, like I'm sure there is a way to like store that in there, but for right now inside the world it's definitely not happy with that. So I will instead, was I creating this component random? Yeah, you're going away. Back down here. Okay, so use this. We want to now also have our let mute RNG equals rand red range. Now that we have rand like this, we can now set velocity dot 0 dot x, and we can just set this to be RNG dot gen range. Arc mutex t. Yeah, I mean, I guess I can. I don't know if I'd be able to do arc stuff inside of ECS like that. I don't know, maybe. This is usually like ECS is usually pretty fast, and I'm not going to have that many entities on the screen. So like right now, I don't think this is going to be a problem. Later on, definitely this will be something we can refactor to like get more speed. Let's see. Velocity, we're going to gen range. So our velocity, let's just say that this is going to be between like negative 10. Ooh, okay. So what if I say it's between -1 and 1.0? That's essentially normalized at this point in time. Now I want to do the same thing for the y. So velocity.0.y. But I also want to now set velocity, like multiply it by some kind of like speed. And that might be like a good one to have in here. If I just have like speed be a magic number for this, let's say velocity dot 0 times equals our speed, which is like, I don't know, 10. I don't need to join you. What am I missing? You also need to be at dot 0, dot 0. Any other errors? It's just this one error. So let's see, mute velocity. Do you need to be a tuple there like that? No. Okay. What did I do wrong here? Oh, that's read storage. Let's see. That's different storages. Do we have dispatcher was not. Oh, here's write storage, so we can take a look at that. Yeah, so it's like mute the position. Okay, mute up position like that. So we only have one thing in here. It's the velocity. So mute velocity. It's not. Yeah, it's the full one here. For velocity in reference to mute velocity. That's exactly what we have. And then dot join. Now I don't think I need the tuple here. No, I don't. And I have write storage out. What am I missing? I'm not using the dispatcher yet. In the run parameters. What am I missing in run? Maybe an extra comma. Oh my gosh, it's that every time. Yes, it's that extra comma. Oh. Yes, I totally forgot. It's that stupid error message that like doesn't tell you what it is. It's because it expected a second thing there because it was looping through. And it's like, oh, length 2. Okay, so this is going to be update our velocity. We also want to update our acceleration. So update acceleration system type system data equals. Okay, so this is going to be our write storage acceleration. Oh, and we also need read storage. I forgot to close you. For our velocity. Self. Okay, so we're gonna have our mute acceleration and just our velocity. System data, not returning anything. Now we want to use specs join. I don't need random. I don't need like the random stuff anymore. So now I'm gonna say for we're gonna have acceleration, velocity, in mute acceleration, velocity dot join. Okay, so that gives us these here. Now what? No method name for join. Really? This problem again? No trailing comma. I guess let me try using, reference to velocity. Error messages here. Okay, so our acceleration and velocity, the way we do this is we just say acceleration dot 0 is going to be plus equals to the velocity. That's it. That's all we have to do here. Dot 0. Okay, so this updates our acceleration. So update velocity, update the acceleration, and then the final, there's a couple last things we need to struct. Update our location. This is close enough to here that I'm just going to copy it. So you are going to be update location system. So we're going to write storage on location. We're going to read on I guess. So you become read storage for acceleration. You become write storage, and instead of velocity, wait a second. No. You everywhere. Come on. Are you not used anywhere else? I guess not. You're going to be our location. On read storage, you become our acceleration. So mute acceleration. This here becomes our location. And our velocity here becomes acceleration. Like that. That should be fine. Shouldn't acceleration add to velocity instead of velocity adding into acceleration? That's a good question. I can't remember. I might be mixing it up behind the scenes. You're probably right. I mean, it'll work. It just is maybe not like what we want to do. And then you think the velocity and acceleration are reversed? I'm writing acceleration. Acceleration at 0 is plus equals to velocity at 0. I think that's right. Oh, like labeling them. Like update acceleration system, update velocity system. Position is meters, velocity is meters per second, acceleration is meters per second squared. All right, well, I'm gonna deal with that later. I don't have time to go through too much of that. And then final, one last struct here, which is gonna be reset acceleration system pull system for reset acceleration system data equals I don't even need a tuple here if I don't want, so I could just have this be write storage acceleration, like that, function run itself. Then we're going to have our new acceleration system data use join, so specs join for this is going to be our acceleration in acceleration dot join. Now I just want to say acceleration dot 0 times equals 0.0. Wait, I can't borrow that? Write storage acceleration. Variable does not need to be mutable. But I want it to be mutable. It has to be mutable here. Does this need to be a tuple? I thought for some reason I saw in the documentation that it doesn't need to be. Then here we need... Okay, apparently it needs to be a tuple. All right, so if I run this in update here, so all right, what are all of our systems? We have update, velocity, acceleration, and location. So let update velocity equals update velocity system. Let update acceleration equals update acceleration system. Let update location equals update location system. Is this specs plus GG easy? Yes, it is. And then let reset acceleration equals reset acceleration system. And now we just run them all in the order that we want them to run. So we're going to start with update. So update velocity dot run now. Self.world. If I just duplicate this, so now this will be update acceleration. And then this will be update location and reset acceleration, run now. All right, it's a lot of code without checking anything to make sure that it works. So let's see if it does. These all need to be mutable. And I think that'll work now. There we go. They're all sort of running around like crazy like that. Now I didn't use delta time properly, so that's why they're not. It's not smooth. So that's something I definitely need to add in for next time. And then I also need to make it so that it they stay within. They're currently trying to get out. They can just move out of the arena too right now. So that's the problem. But that being said, I think this is pretty good. However, I don't have time to do the rest of it, so I do need to come into here. Food randomly moves around. And then I'm gonna next time take a look at it and say, oh, I need to like add in the delta time. So I'll just add in using delta time. All right. With that, I've got to go to stand up pretty shortly. So I'm going to have to run out of here. Anyways, I hope you all have a great rest of your day and a great week. I'll be streaming next time on Wednesday morning at 6:45 a.m. Mountain Time. And we'll get the food set up and then maybe start working on the attraction walker for this simulation. And hopefully we'll be done before the end of the week with the Chapter 2 ecosystem project. All right, with that, have a great rest of your day, and I'll see you next time.